evening to all. Now we going the subject of digital logic circuit, the topic of sequential circuit. The sequential circuit in one topic is flip-flop conversion. The sequential circuit is under the topic of flip-flop conversion. The flip-flop is basically four types of flip-flop. One is D flip-flop, T flip-flop, SR flip-flop, D flip-flop. In that sum we are using conversion of flip-flops. In any flip-flop is input and taken as the output is one flip-flop. First in the flip-flop D flip-flop using SR flip-flops. In that table, the step 1, the two flip-flop we are using basically flip-flop in two types. One is characteristic table and excitation table. We are using which flip-flop is given input is D flip-flop using SR flip-flop. So D flip-flop is the characteristic table and SR flip-flop is the excitation table. Which flip-flop is secondary side? This is the characteristic table of flip-flops, and the characteristic table of D flip-flop and excitation table of SR flip-flop is, what is the D flip-flop characteristic table? What is the D flip-flop is for example delay flip-flop. The 0 means output will be 0, 1 means output will be 1. The same as the excitation table for characteristic D flip-flop. And excitation table for SR flip-flop already we find by using characteristic table. Already we find out the excitation table to map it with D flip-flop characteristic tables. SR flip-flop what is the SR flip-flop characteristic table means based on the input present state, next state. Qn is the present state, Qn plus 1 is the next state. We to find S and R in excitation table. To design the flip-flop conversion means to find out S and R by using K-map. Input is the Qn D and output will be S and R. To find out one equation in S and R. Next, draw the logic diagram of flip-flops. D is the input, S and R is the output variable. So S means S value is D and R variable is D complement. So to use the complement term, Q complement is the next state. And next we are using relation of SR flip-flop using JK flip-flop. In the JK flip-flop is the characteristic table and SR flip-flop is the excitation table. By using characteristic table to find out present state, JK is the input, next state is Qn plus 1. In the JK flip-flop, 0, 0 to find out what is the value of Qn, same as Qn plus 1. 0, 1 is the reset, 0, 1, 0 is set 1. 1, 1, what is the value of Qn? The complement terms of 1. Same 0, 0, 0, 1, 1, 0, 1, 1. Already we find out the excitation table in SR to map it with present state Qn plus 1. And then we find to design the flip-flops in SR flip-flop using JK. So we find out the excitation table to form a variables in S and R. S variable is by using that variable to form a K-map, or variable to form the table to using K-map. S equal to one variable Qn complement J, R equal to Qn of K. Then in that variable S and R is the output, J, K is the input. S equal to Qn complement, Qn is the next state, Qn plus 1 is the Qn is present state, Qn plus 1 is next state. J Qn complement to next state variable equal to S. R means Qn K. So complement undo variable. So using AND gate that to form the design variable. This one common clock pulse is using clock pulse. Okay, thank you.